Dear students, now we are going to discussing about very short answer type questions. Question number 1. What is myopia? How can it be corrected? Definition. A human eye which can see nearer objects clearly, but it is unable to see far objects clearly, then the eye is said to be suffering from myopia or short-sightedness. Let me explain. Let us consider this has to be human eye and this is the eye lens, and this acts as retina. So in this defect, the image of a distant object is formed in front of the retina. So in the diagram, P is a distant object, then P dash is its image. So it's very clear, image P dash of this object P is formed in front of the retina. It is due to the eye remains to converging the rays, and it forms the image in front of the retina. Now, how can it be corrected? P is the distant object. If we consider a diverging lens, is also named as concave lens, which is having a suitable focal length and is placed in front of the eye, then the final image of the distant object is formed exactly on the retina. So, by using a concave lens or diverging lens, myopia can be corrected. Now, the question number 2. Explain Brewster's law. The statement is, the tangent of angle of polarization is numerically equals to the refractive index of a medium. That is, tan IP is equals to mu. So this is called Brewster's law, where IP is called angle of polarization, mu is called refractive index of the medium. Now let me explain. Let us consider this has to be an interface, means which divides two different media. Suppose I am considering a rarer medium, example air, whose refractive index is mu1 is equals to 1, and a denser medium, example glass, whose refractive index mu2 is equals to mu. Both are transparent media. Now, unpolarized light is incident on the interface at a particular angle of incidency, that is IP. This is the representation of unpolarized light. For this angle of incidency, the ray gets reflection. The reflected ray is completely plane polarized, having electric vectors, and a refracted ray having all doubled arrow components and some of the dot components. This is called partially plane polarized light. This is reflected plane polarized light. So from the diagram it's very clear. According to the laws of reflection, this is also IP. For this angle of incidency, reflected and refracted rays are at right angles with each other. Now this is angle of refraction. From the figure, R is equals to 180 minus total, this angle is 180. From that, if you subtract 90 plus IP, then we'll get R is equals to 90 minus IP. Now, using Snell's law, that is mu1 sin IP is equals to mu2 sin R. But mu1 means 1 sin IP as it is. Mu2 means mu sin R means 90 minus IP. From this, mu is equals to sin IP by cos IP. This is nothing but mu is equals to tan IP. This formula is called Brewster's law. Now, question number 3. How many electrons constitute 1 coulomb of charge? Is a very simple question. We know that according to quantization of charge Q is equals to Ne, where N is the number of electrons, E is charge of each electron. From the given question, the given value is charge. Given value is nothing but what? Charge, that is Q is equals to 1 coulomb. And we know that E is equals to 1.6 into 10 power minus 19 coulombs. This is the charge of an electron. And what we have to calculate? We have to find number of electrons. That means N is equals to how much? Formula is Q is equals to Ne. Therefore, Q is equals to Ne. Q means 1 coulomb, N that we have to calculate into E means 1.6 into 10 power minus 19 coulombs. So either sides coulomb cancel out, and we'll get N is equals to 1 by 1.6 into 10 power minus 19. This is equals to 10 by 16 into 10 power 19, or its value is 0.625 into 10 power 19. This is also written as 6.25 into 10 power 19. That means 1 coulomb of charge contains 6.25 into 10 power 18, 10 power 18 number of electrons. Now, question number 4. The question is, 3 capacitors of capacitances 1 microfarad, 2 microfarad and 3 microfarad are connected in series. Then, question number 1, what is the ratio of charges? Number 2, what is the ratio of potential differences? Let me explain. Let us consider the 3 capacitors are connected in series with the help of a battery. Suppose the capacitances are C1, C2 and C3. According to the problem, C1 is 1 microfarad, C2 is 2 microfarad, C3 is 3 microfarad. When the capacitors are connected in series, it's very clear, that is, flow of charge Q is same on each capacitor. Potential divides among the capacitors. Therefore, question number A, ratio of charges. From the figure it's very clear, charge on each capacitor is same. Therefore, ratio of the charges Q1 is, Q2 is, Q3 is equals to 1 is 1 is 1. That is, Q is constant. Now B. What is the ratio of potential differences? We know that Q is equals to CV, but we have to calculate potential differences. So V is equals to Q by C. But in series combination, charge on each capacitor is same. Therefore, the ratio of potential differences on each capacitor is the reciprocal of their capacitances. This is nothing but 1 by 1 is 1 by 2 is 1 by 3. This is nothing but 6 is 3 is 2. Therefore, ratio of the potential is V1 is, V2 is, V3 is equals to 6 is 3 is 2. Now the question number 5. The question is, why is manganese used for making standard resistors? The answer is, resistivity of manganese is nearly independent of temperatures. So it is used to make standard resistors. Now the question number 6. The question is, state Lenz law. The statement is, the induced current will flow in such a direction so as to oppose the cause that produces it. So this is the statement is called Lenz law. Small explanation. Let us consider this has to be a coil. Consider this has to be a bar magnet which is moving. The north pole of the magnet is moving towards the face of a coil like this. North pole of a magnet is moving towards the face of a coil, means the external field is passing through the coil, then it induces a current in a particular direction, that is in anti-clockwise direction. This is the induced current. So this induced current now produces induced magnetic field around the coil. This is the direction of the induced magnetic field, whereas the external magnetic field is passing through the coil. So external magnetic field is opposed by the induced magnetic field which is produced by the induced current. So this is the opposition offered by the coil is according to Lenz law. Now the question number 7 is, give 2 uses of infrared rays. Uses. Number 1, these are used in solar water heaters or solar cookers. Second one, these are used for taking photographs during the conditions of fog and smoke. Photographs during the conditions of fog and smoke. These are the uses of infrared rays. Now the question number 8. What do you understand by the phrase ground state atom? The answer is, an atom in which electrons are not excited and are in ground state. An atom in which electrons are not excited and are in ground state is the meaning of ground state atom. ఇది ఆన్ చేశారా? Now the question number 9. What is the role of controlling rods in a nuclear reactor? Answer is, control rods can control fission chain reaction by absorbing the fast moving neutrons. Example means which materials are used as control rods. For that, examples: cadmium rods, boron rods are used as control rods. Now, question number 10. What is World Wide Web? WWW. Now the answer is, it is a mammoth encyclopedia of knowledge, accessible to everyone, round the clock, throughout the year, through a computer, connected to internet. So this is the meaning of World Wide Web.